Now we want to discuss the topic privacy in the context of smartphones and usage of smartphones. Smartphones are constantly with us. They have become an inseparable companion. They store and generate huge amounts of personal data in all these apps you and I have on our platform. These are calls, these are SMSs, these are contact data, emails, and many other more. Usage statistics of everything the smartphone does. If you run an app, then typically data are produced around that app, and a few of them are stored at the smartphone themselves. The others are stored in the cloud behind the smartphone. There are movement data, GPS, wireless LAN positioning, GSM location by cellular networks, and activity data. Activity data like from your step counters that currently work in almost any smartphone using the acceleration sensor. So all this data, and you see it's a great variety of data, are produced and are stored on your smartphone or on the cloud behind that. And in that moment, I didn't speak about the personal data like photos and videos, which are so easy to take with the smartphone. What are risks around that? So one risk is the online synchronization. Smartphones often perform data synchronization over the internet. For example, iPhones with iCloud, data are stored in the iCloud. With Android systems, data are stored in the Google Cloud behind. And this is important because the small smartphone themselves have only limited computational and storage power. So the huge power of the small devices comes from the fact that behind the smartphone there are clouds used with a huge amount of computational and storage power. And without knowledge of the user, this data are stored in the cloud and are taken from the cloud permanently. So all user settings, for example, all applications and all application data are also stored online. Otherwise, your applications would not work and could not be so powerful. So online account allows access also to other devices. This is a big advantage. If you take another device, a pad or a laptop, you can access the same data as with your smartphone. So this idea to store data in the cloud behind the smartphone has several advantages. It allows that even with the small devices limited in computation and storage power, huge computation can be done. So the smartphone is only used to send the user data to the cloud application and to receive the results. It is also possible by means of these mechanisms that we can access our data from different devices. If the data would be stored on smartphone or on a tablet, then you need to connect it to the smartphone or to this tablet to get access to the data. So this online account provides a lot of advantages. Data is also safe when a local backup is lost, when the device get defect. And data can be restored from anywhere in the event of loss of damages. But there are also disadvantages. For example, the storage of the data on the internet carries the risk of data theft. An attacker can install and delete applications, can recover and destroy data, can unlock phone and other things. So the control over the data in the cloud is not on the same level like the control of the data on your device. By the way, you cannot switch off this. So the access to the Apple App Store or the access to the Google Play Store, for example, in order to install applications, is without an online account technically very, very complicated. I would say it's not possible at all. So this mechanism is needed to make smartphones so powerful as described. Let's have a look on an attack example. An attack on Matt Hannon, an author of Wired.com. This is a journal with a lot of technical insights in that world. So he is a writer for that journal, and attackers used stolen Apple ID from him to delete all data on Matt's MacBook, on Matt's iPhone, iPad, and also his online backups. Let's have a closer look to this attack, because it shows where are attack points. So the attackers wanted to take over Matt's Twitter account. Twitter account contained information about personal website. Using the Whois service, attackers found out Matt's postal address and private Gmail address. This Whois is a service that allows to retrieval and to store data from domain owners. Here, in that case, this were the data of Matt's personal website. By means of the Gmail account's password recovery, an attacker found the email address of the Apple ID. The Gmail system says, we send an email to, and then there is a kind of anonymization, but the attackers were able to discover full address because they know the name of Matt Hannon, and so they could fill also these missing parts. Then the attacker they knew the name, they knew the postal address, they know the private Gmail address, and the email for the Apple ID. With this information, next step in the attacker contacted Amazon and associates a new credit card with Matt's account at Amazon. Then the attacker contacted Amazon again, got the password restored. This is possible by knowing the previously added credit card number. This is taken for security, that the one who asked for the password restoring, that he knows the credit card number. And then attacker found the last 4 digits of a genuine Matt Hannon credit card on the Amazon account. The attacker now knew name of Matt Hannon, postal address, private Gmail address, email of the Apple ID, and last 4 digits of Matt Hannon's credit card number. With that information, the attacker contacted AppleCare and got access to the Apple ID by knowing the name, the address, the email address, and last 4 digits of the credit card number. This is what the one who requests such an Apple ID must know. And with the aid of the Apple ID and access to Apple's mail account, then the attacker reset the Gmail password and then also the Twitter password, and deleted all data from iPhone, from iPad, and from MacBook from Matt Hannon. So you see a careful interplay between the different services and had helped the attackers to get access to Matt Hannon's devices and to Matt Hannon's account to delete data. Of course, this is a great energy which was spent to perform this attack. It was a smart attack, and Matt Hannon reconstructed this and documented it in detail so that we could show this to you. Another risk are applications, apps that are run on a smartphone. In addition to the online synchronization of the smartphones, each application can synchronize the data with its own server, because the smartphone and the cloud of the smartphone, the Apple Cloud or the Google Cloud, they provide the possibility for the user to install applications from different providers. So also by means of the online synchronization with the Apple and the Google Cloud, also the data to the server of that application's owner are exchanged. So each app, this have different data protection policy. They come from different countries. They are in different ways careful with the data. So apps can, for example, also access user data from other applications. They can access, sometimes they need to be able to access GPS information or camera. What kind of other applications they can get data access. This depends from the so-called authorizations. So, for example, in case of Android operational system, the possible required authorization can be displayed during the installation of the application. So here is an example that shows the information behind, and it shows exactly to which data the application has access. In this case, to the device and app history, to photos, media files, to the Wi-Fi connection information, to Bluetooth connection information, and device ID and call information. Typically, the user has a possibility to say yes or no if in the course of installation of an application, the question comes to him. But for many applications, authorizations are needed, otherwise they will not work. Here's an example, a flashlight app that wants to have access to camera and location information. So the question is it necessary to allow a flashlight to get know where is the place the people are, the user is standing. So in Android, it's possible to block individual authorizations, and this is possible at least since the version Android version 6.0. So 6.0 and higher, they allow here to, for example, deny, in the case of this flashlight app, the deny of location data. So Privacy Guard on Lineage OS still can have more options. In case of Apple iOS operating system for the smartphone, also Apple iOS allows blocking of the authorization in the settings. But many users are not aware of this and are not critical enough if they allow an application access to other data of other applications. Every time remember to the flashlight example, which shows that, for example, access to the camera or access to the location data are completely unnecessary for the purpose of that applications. But the designer of this app often designs the app only for the case, only for getting data back from the users. So application authorizations only control the access to the data. So the internet access should actually be separately controllable for individual applications. For example, by using a firewall. But not possible, this is not possible with standard tools of smartphones. As a user, without this information and this expertise, it is impossible or very difficult to do this. So here, for example, an AF wall plus on Android requires root access to install such and to select such authorizations. So the firewall IP for iOS is only available after a jailbreak. So for the typical user, this is not. And so the typical user has to live with the standard settings and is not able to do individual settings. What is unavoidable for the users? So the monitoring by the manufacturer and backdoors. For example, here are some examples that happened in the past. So popular example from 2011 was that all location data of the iPhone was saved in the consolidated.db file and then sent to Apple. So Apple completely get access to the location data of the owner of the iPhones. 2014 there was another event that became popular and shows how problematic situation is with privacy in smartphones. The developers of the Replicant, this is a free Android distribution, claim that all Samsung Galaxy smartphones have a backdoor in the modern software which allows access to the file system. Or in 2016, Xiaomi can remotely install apps on customers' devices without knowledge and without agreement of the devices. In 2017, OnePlus 2 sending fine-grained usage statistics of application usage and users' behavior to the cloud. Of course, many of the things are created to improve the quality of the service, to better know the user and to adapt to adapt the different offers to the real wishes and needs of the users. But this needs to be done in an open, transparent way so that the user has a chance to say yes or no. There are more things that are unavoidable for the users. For example, mobile tracking by cellular network and data retention. In order to be able to make a call, the cellular network must be able to determine the current cell of the cell phone. For example, to know exactly where is the user that want to make a telephone call, what is the closest cell, or what is the cell he is located, because this is necessary. Otherwise, the system could not receive the call and send the call and provide the connection to the user. So the telecommunication providers in most European countries were obliged to store such traffic data and connection data for specific time periods. This is in connection with security question, with public security, and with the idea to be able to investigate criminal activities. But in this way, also data from other persons is stored and can be seen.